Hello. If you're building browser-based games, you're probably using one of the many 2D frameworks like Pixie, Phaser, or GDevelop. Almost all of these engines use a canvas element or WebGL to render sprites and graphics. For many types of games, it's actually possible to use the DOM and regular HTML elements as your rendering engine instead. This is particularly true for casual, idle, and puzzle games that don't require high-performance graphics. These comprise just over half of all games out there, and they're the fastest growing segment of games. I'm personally using DOM-based rendering for my browser-based games like Rogel. There are a number of advantages to using the DOM as your game engine, which I'll cover in future, but now I want to take a look specifically at using CSS on DOM elements for effects in browser games. CSS, or Cascading Style Sheets, is a highly performant declarative rendering system which uses hardware acceleration on most devices under the hood. You can find code for all of these examples in my GitHub under chr15m/juiceit. There's also a demo page where you can try out every demo on your device. The name Juiceit is a reference to the famous Juice It or Lose It video, which is a really cool hands-on talk about why game feel and juice effects are important in games. So let's take a look at CSS for basic animation, movement and positioning, particle effects, and finally a quick look at animating non-game elements like UIs and HUDs with CSS. We'll start right in the CSS wheelhouse with some simple animation effects. Here we have a very simple hover effect. The ghost is a DOM element containing a Twitter emoji. We have a 1-second infinite hover animation attached to the element with a class, which just moves it up and down with an ease in-out timing function. If we remove the class, you can see the ghost stops hovering. So turning that hover on and off programmatically using JavaScript is a very efficient one-liner. The shadow here is an SVG element, which uses a simple scale transform to change size. Next, let's look at a little interactivity. This entity has a simple on-click handler, which changes a couple of classes on the element. First, it adds the Juicy Bounce class, which contains the bounce animation and the shadow animation. It also changes the sprite by changing the Twitter emoji class to Zany Face. The sprite has an onAnimationEnd event handler attached, and when this fires, it removes the bounce class and sets the emoji class back to the grinning face. Shake is a classic animation effect to convey different events like an entity getting injured or even positive things like a power-up. You can see here varying intensity of shake as we click through, and of course the sprite itself is changing for extra effect. This shake effect is achieved with subtle to less than subtle movement and rotation on the order of a couple of degrees. As the intensity increases, the amount of positional and rotational movement increases, and the loop time for the animation also decreases so it feels faster. If I slow the animation right down, you can see it in detail. What's cool about this is it's actually a loop, but for some reason you can't really tell. This is similar to tiled backgrounds that manage to hide a repeating pattern. If the looping is a problem, you can also create two nested elements with two slightly different animation loops with different lengths so that they never repeat. Screen shake is the absolute classic game juice move. I use this all the time in my game Asterogue. As your weapon power increases, the screen shake gets more and more dramatic when you enter combat with monsters. It's a great way of conveying something powerful happening. This works basically the same way as the last example, except it's applied to the container element instead of individual sprites. Now let's take a look at using CSS to position things on the screen. This is really what makes the DOM viable as a game engine. It's often more performant to have the hardware-accelerated CSS rendering engine position something than it is to use JavaScript to move the actual element position. This coin up animation could be used in a game when your character collects something, like a coin or a gem. It's got a very simple animation loop that just uses transform translate to position the coin. Once it's bounced, the coin is removed when the onAnimationEnd event fires. You can also move an entity to a specific position by setting properties on the entity element. In this example, we're setting the transform values directly in the style, but you can also do this using CSS variables. So for example, you could define a CSS variable entityX and set that on the style, and then use that value in the CSS with var entityX. You can see in this animation, we've given the walk a little extra juice just by rotating it and bobbing it up and down as it moves. That gives a lot of life to a simple Twitter emoji. Let's look at a slightly more complex animation now just to see what's possible. Here we have two sprites with multiple phases, and also some particle effects that I'll get to next. We queue up different animations on each sprite, and after a set amount of time, we add the particles, which have their own class. So let's take a look at these CSS-based particle effects. What's happening here is when we click, 20 particle sprites are added with the Juicy Particle class attached. This class uses CSS variables for jump, direction, spin, and size, and the JavaScript randomly assigns numbers to each of these values so that we get a wide variety of particles going in different directions with different size and spin. This is another example of using CSS vars to really squeeze a lot out of a single CSS animation that is not that complicated. In this case, each particle actually has a wrapper with an inner and outer element, so that the overall positioning of the vertical and horizontal components of the arc can be applied separately. This points to a basic limitation of CSS where you can't stack animations on top of each other. This might be fixed in future versions of CSS, but for now you can use a wrapper element for each stage of the animation like we did here. To give you an idea of performance, we can click a lot of times, and we don't see any degradation when we hit 100 or more particles. You're never going to get the same performance as WebGL or a native game, but for a lot of idle, casual, and puzzle games, 100 particles is more than enough. These bubbles are similarly created, one per click. The wobble is scaling and the movement is basic positioning. Again, you can fire up a lot of bubbles and not see any performance drop. Finally, here's a simple smoke particle effect that works the same way as the previous ones, but with the addition of opacity fading. Apart from juice animation effects on game entities and sprites, you can use CSS for the usual things like animating titles and other game UI elements. For example, in my game Asterogue, the heads-up display is animated with CSS. So that's how you can use CSS to give your browser-based game some juice. Check out the repository on my GitHub at chr15m/juiceit, where you can find all the CSS code, and best of luck with your own CSS game juice adventures. Thanks for watching.